Hello everyone. In this video we're going to be talking about the end behavior of rational functions. So the topics are going to be horizontal asymptotes, slant asymptotes, and then we're also looking at end behavior, obviously. So end behavior is going to be the same as we learned before. You always have this form. As x goes to negative infinity, y goes to something. As x goes to positive infinity, y goes to something. This is not true for exponential functions, but it is true for rational and polynomial functions. So if there is a horizontal asymptote, both ends will approach the asymptote. So that's easy enough. If there is no horizontal asymptote, then the ends will either approach negative infinity or positive infinity. Okay, so let's look at some examples. We're looking at number one. What we're going to do is we're going to look and see if there's a horizontal asymptote. If there is, then good. If there's not, then we're going to look at Desmos and see where the ends point to. So in this very first one, the degree of the numerator is 2. The degree of the denominator is going to be 1. Okay, so that means that the degree of the numerator is greater than the degree of the denominator. So let's just pull up this guy. Since the degree of the numerator is greater than the degree of the denominator, then we do not have a horizontal asymptote. That means we have a slant asymptote. So we have a slant asymptote. So let's go look and see what these ends do in Desmos. But before we do that, let's just write our form. Okay, so let's go on to Desmos, and we're going to type this guy in. X squared minus 9 divided by 3x minus 3. And here is our equation. If we look on the left side of our function, we can see that this is going down. This is in negative infinity down here. So as we're going to the left of our equation, is we're looking at that first one, x going to negative infinity, y is also going to negative infinity. And likewise on the other side, on the right side, this is going towards positive infinity. You can see this is existing on the positive side. So we're going to have from negative infinity on the left and positive infinity on the right. This means left. This means right. Okay, so let's go to the next example. And first we're going to look to see if there is a horizontal asymptote or not. And we can see that this one still has the degree of the numerator greater than the degree of the denominator. And let's maybe switch this one up a little bit. I'm just going to put a negative out in the front. Okay, so the degree of the numerator is greater than the degree of the denominator. That means there's going to be a slant asymptote. Okay, so that means both of the ends are going to be on a line like this. So let's go look in Desmos. Okay, and here we go. You can see both of the ends are on a line. That's what we mean by a slant asymptote. And the real reason, just by the way, is that x to the third divided by x squared is going to give you x. So that means that this function eventually will become x at the end. Or negative x is really what's happening. But anyway, so here's our slant asymptote. We can see that on the left, this is up in positive infinity. And on the right, it's in negative infinity. So it's going to be the opposite of our last one. On the left, it's going to be up in positive infinity. And on the right, it's going to be down in negative infinity. Okay, so let's try out another one. And we'll try out some without slant asymptotes. So these actually will have horizontal asymptotes. So let's look at this first one. The degree of the numerator is equal to the degree of the denominator, so it's going to be the ratio of their leading coefficients. The leading coefficient at the top is 1, so the horizontal asymptote is at y equals 1 over negative 3, which is the same thing as negative 1/3, so I like the way that looks better. So the cool thing is that our asymptote is going to pull everything towards it at the ends. So let me just type this in and show you what I'm talking about. Okay, here is our function, and these should be approaching y equals -1/3. And you can see that it does fill in that gap there. But both of the ends are going towards that line there that we just had. So if I look on the negative side, it's getting really, really close to that -1/3. And the same thing if I look on the right side, it's also getting close to that -1/3. So this end behavior is quite simple. As x goes to -infinity, y goes to -1/3. And as x goes to positive infinity, y also goes to -1/3. So this one is pretty simple because it does have a horizontal asymptote. So the answer does kind of give itself away. Okay, and let's look at this last one over here. And let's just switch up what this one is as well. Let's just make this 4x³ over -7, just because I can do that. It's so cool. Okay, so looking here, these do have the same degree on the numerator and the denominator. So the horizontal asymptote is going to be the ratio of their leading coefficients. Okay, so the horizontal asymptote here is at y equals 4 over -7, which is the same as -4/7. So let's just try to write out our behavior before we even go. Both of these should be going to -4/7, but we're going to go and check in Desmos. Okay, so let's go to Desmos. Okay, and here is our graph that we have here. That black line is pretty strange. I'm not really sure what's going on there. Oh, I see. I just wasn't zoomed in enough. So yeah, there it is. Okay, and let's look and see what our horizontal asymptote is. It's y equals -4/7. Okay, and what you'll see is that as we look really far away on the ends, this is going towards that. Yes, it's going through the function, but we're not worried about what's happening right here. We're looking at the end behavior. What is happening on the left side? What is happening on the right side? And both of these are approaching -4/7. So we do have the end behavior correct here. And hopefully this seems pretty simple to you. Basically, if there's a slant, you look and see what the left and the right side are doing. And if there's not, and they're horizontal, then you can just write the end behavior going to those asymptotes. Okay, hope that you guys have a great rest of your day, and goodbye.